Hello friends, welcome to our channel Knowledge Amplifier, and in this particular video I am going to discuss some important MCQ based on k nearest neighbor algorithm. So let us start with the first question. Which of the following will be true about k in knn in terms of bias? Option A, when you increase the k, the bias will be increases. When you decrease the k, the bias will be increases. Cannot say. Option D, none of these. So obviously the correct answer is correct, option A, right? Because bias is nothing but error with respect to training data set, and when your k value is small, then the error with respect to training data set is very small, that is bias is small. Okay, so that time model suffers from overfitting, and if you keep on increase the k value, model will eventually suffer from underfitting, and that time error with respect to training data set will also increase. That means bias will increase. Just you need to remember this graph. Okay, the explanation I have already covered in detail in my previous video. You can check the link given in the description to know more about this particular graph, how the test error and training error varies, how the bias and variance varies, how the decision surface changes with change in k. Because k, this particular one, you need to understand the effect of this particular k value very in a very clear way to understand or give this kind of answers. Okay, because this is the main hero of the whole algorithm. So you can see here, for small value of k, the training error is actually when k equal to 1, there is 0, and eventually it starts increasing. So if k value increases, training error increases, that means bias will increase. So obviously correct answer is option A. Then next question, for variance what will happen? Okay, so what we have seen for variance, so initially it is very high, then if we keep on increase the k value, it is basically decreasing, and then again it starts increasing at very high value of k. So let's discuss what is the question. Which of the following will be true about k in knn in terms of variance? When you increase the k, variance increases. When you decrease the k, variance will increase. C cannot say, option D, none of this. So obviously the correct answer is option B, right? Because when you decrease the k value, for small value of k, the model suffers from overfitting, and in overfitting zone what happens? The error with respect to training is less, but the error with respect to test data is more, and error is with respect to test data is nothing but variance. So if you decrease the k, obviously variance will increase, right? Next question, when you find noise in data, which of the following option would you consider in knn? Option A, I will increase the value of k. Option B, I will decrease the value of k. Option C, noise cannot be dependent on the value of k. Option D, none of this. So the correct answer is, no doubt, I will increase the value of k. Now why I am telling what is the explanation or design behind this? Just the same explanation like we have discussed, how decision surface varies with respect to k value, right? So if you just recall, for a very small value of k, when we have taken this knn classifier for k equal to 1, okay, suppose we are considering k equal to 1, that time we have seen for a single noisy data if present, suppose this one, actually we have applied this based on sepal length and sepal width in the popular iris data set. You can see this blue one is basically iris virginica. It is coming as noise in this region because this is the region for iris setosa and iris versicolor, but this here one iris virginica is coming, and due to which a large region is basically getting the classified basically as our iris virginica. So this is basically highly suffering from noise, and when you increase k value, then majority voting will come into picture. Then after doing multiple votes, then it might happen the priority goes to some maybe iris setosa or iris versicolor, right? So basically I will increase the value of k when our data set, training data set, has some error. Okay, so option A is the correct one. Then next question, below are two statements given. Which of the following will be true for or both this statement? Option A, knn is memory based approach, that is nothing but the classifier immediately adapt as we collect new training data. B, the computational complexity for classifying new samples grows linearly with the number of samples in the training data set in the worst case scenario. So the correct answer is nothing but both of these are true, right? Why? Because see, KNN is memory based approach. Yes, it is memory based. It has no computation like other algorithm during training phase, right? Nothing to calculate any particular value for optimization or hyperparameter tuning like that. Whenever new data set comes, that time it try to calculate distance with respect to all other data point and take the nearest k value, and for classification it apply majority voting, for regression it apply mean or median. So that means it is memory based approach. Okay, it just store the training data as it is in the memory, never compute anything. So that's why it is called memory based approach. And suppose I am having 5 data points in the training set. Now one new data point is coming. So what I have to do? I have to compute distance of this new data point with all the 5 data points present in our training set. Now suppose I am increasing the training data set to 6. So what it has to do? It has to do one more distance calculation for the extra training. Okay, if I increase one more training set, suppose my training set is now 7, then it has to basically calculate one more Euclidean, Manhattan or Hamming distance. So that means it is increasing linearly with our training data set. Okay, right? So basically both options are correct. Then the next question, you are given the following 2 statements. Find which of these options are true in case of KNN. Okay, it is in case of very large value of k, we may include points from other classes into the neighbor. Option B, in case of too small value of k in the algorithm, it is very sensitive to noise. So obviously, no doubt, correct answer is both. Why? Because this already I have just now discussed that to avoid the noise, you have to increase the k value. For that is because for small value of k, it suffers from or highly sensitive to noise. It basically make prediction based on that single noise. There is a huge probability, and in case of very large value of k, obviously it is quite clear that there is a probability that we might consider for majority voting, we might consider some point which is belonging to other classes also. This is quite simple. You can understand if you know the KNN algorithm actually, right? So next question. Which of the following statements is true for KNN classifier? Option A, the classification accuracy is better with large value of k. Option B, the decision boundary is smoother with smaller value of k. Option C, decision boundary is linear. Option D, KNN does not require any explicit training step. Okay. So see, try to understand. Decision boundary is linear, not at all true, because just now I have shown you that this is kind of decision boundary what we get. Like in case of decision tree, we get that kind of linear decision surface, right? But decision boundary is not at all linear for KNN. Okay. Then the decision boundary is smoother for smaller value of k. Again, this is false. For smaller value of k, it is highly sensitive to noise. So as a result, decision boundary is not smooth. If you keep on increase the value of k, the decision boundary will become smoother. The classification accuracy better with large value of k. If you just recall the graph, see, if you keep on increase the k value, after a certain point of k value, test data error also increases, training data error obviously increases. So it is also not correct that for large value classification accuracy is not going to be very better. So no doubt the correct answer is D. KNN does not require any explicit training step, and that's we know that in training it does not do anything. Just computation, whole computation is based on test data. So option D is the correct one, right? So I hope these concepts are clear to you. These are some very important quiz question or interview question you can consider for machine learning or data science related placement process. This is all for this video. Thank you for watching.